Hello guys, welcome back to Technology Universe. Today we would be going to study data structures. So first of all, let us dive into the basic concepts of data structures. In the first video, this is the part 1 of data structures. In the first part, I would be explaining you what are the different types of data structure, what is a data structure, and also how are they going to represent and how we are going to retrieve data in programs, or how we would be implementing the programs, just the algorithm or just the necessary steps would be discussed in this first video. And for the programmatic approach using Java, just refer to the next video, the part 2 of data structures in my channel. Go to the video section and search for the part 2 of data structures and go forward with the programmatic approach and how I am implementing a stack using an array in Java, or how I am implementing a queue using an array in Java. You can get those in the part 2 video. So now what is data structure? Data structures are, you can say, they are a particular way of representing data in such a way that we can handle that data by giving some conditions maybe, or we can retrieve the data easily whenever we need it, using a particular pattern or particular discipline. So data structures, what they help us, they help us to organize the data in such a way, in a unique way, and we can retrieve and manage the data efficiently. Okay, you know that in every application in this information technology world, billions and billions of data are being processed and are generated. So it's of high need to store those data in a systematic and well managed order. So data structures helps us to organize the data that is generated in every step in an application run. So those data are stored in an effective manner in certain well-defined structures. These structures are known as data structures. So the first fundamental structures that are to be taught in class 12 ISC syllabus, as per ISC syllabus, is the first one is stack. The next one is queue. There are some different types of queue also. I would just mention them as well. And we will also see what is a linked list or a list. Okay. So one by one, let's go through. The first one is a stack. A stack, the name suggests that it's a stack of something, some objects. Just refer to a stack of books on a tabletop. Just imagine that there is a pile of books on your table, and if you want to move a book, then from where you would remove a book, you would remove a book from the top, right? Normal human being would do that. You can obviously remove a book from anywhere, but a normal human being, unconscious being, would take a book from the top only, right? So just as a stack of book or a pile of books, you add a book or you delete a book or you remove a book, always these operations take place from the top only. So the stack follows a pattern that is known as FIFO. Sorry, it's LIFO. It follows LIFO. LIFO stands for last in, first out. Like in a stack of book, what you can see that the last book that you have put, that one only gets out when you remove a book, right? The book I just kept at the top of that pile of books, the first one, the topmost one is going to be removed first, right? So the last element that is entered will be the first element to be removed. So this fashion is known as LIFO, or last in first out, and this algorithm is followed by which data structure? It's followed by stack. These are some of the small questions that you can have in 1 or 2 marks question that what is a stack. Stack is a data structure that follows LIFO fashion or last in first out fashion. Okay, this stack can be implemented using arrays. Okay, that we would be seeing in the next video, that how we are using an array to implement the functionalities of a stack. In a stack, the operation to add any element is known as push operation. It is called pushing. Okay, if you want to remove an element from a stack, it's called pop. It's called popping. Okay, this is a function. And another important term that you would hear here is top. Okay, top is just a variable, or you can see it's a pointer that points to the topmost index or topmost position of the element or in the stack, the topmost position. Suppose there are 15 books in a stack, so in the topmost position is 15. So that's the top. If I remove a book, the top gets decreased by 1. The next For the next step, the stack, the top becomes 14. If I again remove a book, the top becomes 13. So likewise. So top refers to the topmost index or topmost position in a stack of data, right? Just in the case of books, you replace the book with data packets. The data packets can store integer, string, float, long, anything. So those are data packets instead of books in programming world. So stack follows last in first out. Just I'm summarizing the points once again. So LIFO stands for last in first out, that is being followed by stack data structures. Any element that is being added, that process is called pushing. Any element that is being removed, that is called popping. And the topmost element, that point or that index is called the top. Okay, all pushing and popping takes place from the top. This is a note point to be noted, that any pushing or popping operation takes place at the top of a stack. Now suppose I have a stack. Now it's an empty stack. I am pushing 5. So now stack becomes 5. The topmost index is 1 only. Okay, suppose the top is 1. Index is 0, but position is 1. Okay, in an array always the position starts from 0. So the top is here, the top is 0. Suppose I want to add any another number, suppose 16. So now the top is 1, and what is the value in the top? That is 16. Okay, suppose again I want to push another number, suppose I want to push 99. So on the top of 16, now I would be adding 99. So what is the top now? The top is 2, right? Suppose I want to pop now and to pop a number. Popping means just removing the topmost element, that is 9. Here the topmost element is 99 at index 2, 0, 1, 2. So if I pop now, the stack becomes 516 and the top becomes -1, that means 1. So pushing means adding an element in a stack, and popping means removing an element of the stack from the stack. Okay, so that's a pretty basic understanding that you need to understand for implementing some programs with stack. So it's a stack data structure. Next on the list is queue. Now the name of the queue suggests that it's a line, right? Queue means it's a line. You are standing in a queue means you are standing in a line. And this you might have experienced in some booking counters, or in some places where people stand in a queue, or you have gone to a election booth and to cast your vote, so you're standing in a line or you're standing in a queue. So the first person who is standing in the line would be the first person who is getting to be served. So the discipline that is followed in queue is FIFO. It's called FIFO. FIFO stands for first in, first out. That means the first person that is going to enter in the queue would be the first person to get out. Okay, so that means first in, first out. Now just in place of person you replace it with data packets. So the data packet that have entered first, that would be the one that would be going out first. Okay, first in first out, first come first serve strategy. This strategy is called FIFO, and it is being followed by which data structure? It's followed by queue. This can also be a short question, or you can uh, have this in Viva or anything else as well. So just get prepared with these basic concepts very well. And here, unlike top, here there are two indexes that are known as front, and another one is known as rear. The front stores the index of the topmost element, and the rear stores the element of the last element. Okay, in a queue, if you are standing in a queue, suppose in the queue the first element is 4, the next element is 5, next 6, next is 32, again the last one is 45. So the top is the first element that I entered is 4, so this position is top, this position is front, then front is 0. 0, if the index starts from 0, 4 is 0, the 5 is in 1th position, 6 is in it 2th position, and so on. So the front is 0 and the rear is 0, 1, 2, 3, 4. The rear is 4 here. Okay, so this is the front. I'm just mentioning is at capital F, and the 45 is the rear. Okay, R. Okay, if I want to add an element, then that would be added at the last only. Okay, because the first person who is standing in the queue would be the first person who is would be served. If you add anyone in the beginning, that means what would happen? That person who is getting served, that is getting added at the last, would be getting served, but that should not be, right? We should have this strategy as first in first out. So we cannot add here, you have to add here just beside 45. That means adding any element, and the process of adding any element in a queue is called enqueue. Entering an element in a queue is called enqueue operation. If I want to add any element, if I want to enqueue an item in a queue, that would be added. Where it would be added? It would be added to the rear position. Okay, it would be added here. Suppose I want to enqueue. I'm giving a command as enqueue 67. So what it would process and give me, the first element is 4, the next one is 5, the next one is 6, the next one is 32, the next one is 45, and the last one that I have just entered would be 67. So 4 is the element in the front, and 67 is the position, is the data that is stored in the rear position. So front is the element from where we are getting the elements to be removed. Suppose I am giving a command to delete an element from this queue. That process is called dq. Okay, dq. Suppose I am just running dq. That means it would remove an element. I have not given any parameters here because I don't need any parameter, right? Just I need a dq, deletion operation. Deletion from where? Deletion from the first, because the first person that has entered in the queue would be eliminated first, right? So 4 would be popped from the queue. So dq, one time if we run the dq, then the queue would look like 5, then 6, then 32, then 45. Here the front is 5 and rear is 45. Also there is a 67 as well. So rear is 67. Suppose I want to dq again. I want to dq again. Then what would be the queue now? The queue would be now 6, then 32, then 45, then 67. Okay, so that's pretty much of the queue. So I'm just summarizing what is a queue. A queue is a data structure that maintains the discipline as FIFO, first in first out. And you just remember the example of a set of people standing in front of a booking counter or in a ticket counter, or people going to cast a vote in an election booth. So those people, though in those scenarios, what happens now? The data packets are standing in a queue. The first data packet that has entered would be the first one to be getting to be served. So That type of data structures are called queue. Here queue, what positions you have to remember, there are two terms called the front and the rear. Front points to the position where the first data packet is stored, and rear stands for the position that is the last one. Okay, the last data packet position is the rear and the first data packet position is the front. Entering any element in the queue is called enqueue operation. Deleting any element from the queue is called dequeue operation. And how it operates, I have just shown you with an example demonstration. That would be enough for grasping the concept about queue. So next on the list is linked list. Now the above two items, the stack and the queue, these are linear data structures, and these data structures, whenever they are being implemented with the help of array our in our hard disk or in our programming world, the data is stored in contiguous cells in hard disk. Contiguous cells means, suppose there is a cell in a hard disk. A cell is a small area, you can say, where data is stored in an electronic manner. Electronic means in patterns of zeros and ones. You know that data that is stored in the hard disk or in any uh, lower level platform, it is stored in combinations of zeros and ones. Okay, the data you are seeing in the screen now, that is being converted from that 01 language to your human readable language, right? So those cells, they store data. And in queue and stack, these are also ways to store data. So they are some interconnected framework of those data cells in the hard disk. For queue and stack, those cells are contiguous, means those cells are placed side by side in a continuous fashion. Suppose this first one is cell number 1, cell number 2, cell number 3, cell number 4, so on. So if I book a stack area of 10 cells, those 10 cells would be continuous, means they are located side by side in the hard disk. Or the queue, the for queue would also be the same, more or less the same. But for linked list, suppose there are no continuous cells present in our hard disk, so I would not be able to book any space in a stack, any stack space, or in a queue or a queue space. So will I not be able to store data then? That's a problem now. So the answer to this problem is the concept of linked list. A linked list is a list of data items where data items are stored in cells which might not be placed continue in a continuous fashion in the hard disk. They can be located far away, but they are linked to each other. That's why they are called linked list. I repeat that linked lists are special data structures are list of data items where data items are stored in cells or in places which are not located side by side or in a continuous fashion in that hard disk. They are located in a far away, but they are interconnected or linked to each other. That means, suppose there is a cell here. This cell stores a data, and it has also a separate space where it would store the link of it would store the address of the next cell located in the hard disk where the next data is placed. Okay, this link points to another cell. So this is a linked list block. Okay, we say it as node. So this is a node. So in a node, what are the two items in a node? One item is the data, another item is the link. So a linked list node contains two compartments. You can say two compartments. One compartment stores the data and another compartment stores the address of the cell where the next data item is stored. So next data item, suppose it is stored in this block. So here also there would be a place to store data and another compartment to store the link of the next address where the data is stored in the hard disk. Okay, suppose the next node is the last node in the list. So here what would happen in the link part then? This link part would be null. Null means this is the end of the linked list. So this is a list of data items which are linked to each other. This is the link. Suppose the address of this cell, this DDDD, is 506. So in the link of the previous node, I have to store 506. Suppose the address of this node, suppose this is the A node, this is the B node, and this is the C node. So the address of B node is 506, where I have to keep 506 in the link part of the previous node. Now suppose the address of the C node is 602, so I have to place the address in the link of the previous node, 602. And since there are no nodes just after the last this one 602 address node, so I have to keep null because it is the end of the linked list. So linked lists are what they are linked data packets in a list. Okay, in a list, it's a list of data packets, and these data packets are stored in hard disks, and they are not in a continuous fashion, and they have two compartments. One compartment is used for storing the data, another compartment is used to store the address of the next linked list node or the next node of the list. Okay, so this is linked list. So we basically have these three structures in ISC syllabus, and in queue there are some varieties as well. Just know the definitions and the qualitative explanations only. We have priority queue. Priority queue means a queue. In this priority queue, we would delete those elements only which have highest priority. If I set priority that 32's deletion priority is highest, then instead of deleting the number at the front, that is 4, instead of deleting 4, what we have to delete? We have to delete 32. So in priority queue, the element which has the highest priority would be served the first. Okay, that is called the priority queue. Okay, another thing, we have circular queue. In a circular queue, what we have the data stored in a circular fashion. Okay, so it's a circular fashion, the cells are located in a circular fashion, that is called circular queue. So priority queue, circular queue, normal queue, stack, linked list, these are the basic data structures, and these data structures are required to store data in a well organized format that would be helpful for different scenarios. Based on different scenarios, we will be choosing different data structures. Suppose for one scenario stack is doing well, so we would use stack. For another scenario, if linked list serves us well, we would use linked list, and so on. Based on our requirement, we would use the respective data structures. Okay guys, that's all for today. Okay, I think that's quite enough for the introduction, or the quite enough for that qualitative definitive explanation of the different types of data structures. Just look for the next video to get the Java implementation of stack and Java implementation of queue. Okay guys, take care, study well, best of luck, meet you in the next video.